Let's continue our discussion by looking at the internet. Now, generally there's two types. Whenever it's explained with a capital letter I, it usually refers to the content when people talk about websites or web pages. However, there is another form of the word internet with a lowercase I, which typically refers to the number of networks that are linked together that enables us to send communication and information on this wide area network. Now let's go and look a little about what the internet is. I'm sure everybody realizes that the internet is a global phenomenon, and it allows us to share information and to access information that's delivered right around the world. So there's international scope and there's people in each and every continent. The internet had a huge impact on our daily lives, including politics, and we would typically find that whenever there's riots in countries and people try to overthrow governments and those kind of things, that they do make use of internet resources, facilities, and aspects such as Twitter and Facebook. And in many countries, they actually go and they prevent people from talking to each other by blocking these types of facilities. Now, internet censorship do actually take place quite a bit. If we think, especially in certain Asian countries, they do strictly control what the citizens of those countries can actually view. So you would find that whenever you try to go to a specific site, that you would get a message, and that message would indicate that according to government regulations that the information is perhaps not permitted. So unfortunately there is still a lot of restrictions. Now if we look at the graph, that gives us an indication of the growth of the internet. Now the internet roughly started in 93. Now this is the internet referring to the content. So web pages and websites typically started around 93, and we can see that there's been exponential growth, and nowadays companies and individuals need to know about the internet. They need to know about web content and how to use that. Now let's try and look a little about some of the users. If you look at the graph on screen, you will note that Asia has about 45% of all internet users. Now the statistics that's presented here was roughly around 2015, so it's a bit outdated. But Asia 45%, and if we look at Africa, a meager 7%. Okay, so there's still a lot of potential and growth for Africa. Now what is the internet? As I've mentioned, we do get two types. Capital letter I is the actual content, and then the one with the lowercase I, that is the computer network, the actual computer network. Now, in our previous discussion, we talked about network types and we talked about wide area networks. Now, the internet is actually a set of wide area networks. So it's all the networks around the world that are interconnected that allows us to exchange information between each other. Now you guys will see that they're talking about protocols. Now protocols refer to the rules that govern the exchange of information. For example, if we talk about email communication, for you to send out an email, a specific protocol should be followed, and that protocol is actually referred to as SMTP, or the Simple Mail Transfer Protocol. So SMTP actually tells us that we need to establish a link between the sender and the receiver. So we need to know who sends the message, who's going to receive the message, what is the message that we actually want to send through, the body, the content of the message, and then also what is the subject of the message. And perhaps lastly, do we have any attachments to that particular message? So that would be considered the protocol. Now if we continue talking about the internet, the whole idea behind the internet was to provide fast, efficient and error-free communications. Now if we think back, before the internet we had networks, we had communication, but those were prone to a lot of errors. And the internet tried to address that and to ensure that whenever people wanted to send information, they had the ability to go and do so. Now the internet originated from a military network actually, It was developed by the United States Department of Defense, known as ARPANET, where they wanted to send communication between the different units during war times. So that was extended. Academics saw the need of that and actually extended it, and this is what's known as the internet today. Now the next thing we need to refer to is the internet protocol. Now, as mentioned before, protocol is a set of rules. So whenever you want to work on the internet, you also need to work with protocols, and one of the protocols we're going to touch on is the internet protocol. Now, the internet protocol enables us to send information from one network to another by following routing techniques. Previously, when we've spoken about topologies, we've spoken about messages that hop from one node to another, if you think about mesh networks. So it's going to use a similar concept. So you will send information from one network to another, and the message will actually hop between the different networks. Now, there is rumor that people are working on Internet 2, or also referred to as I2, which is the next generation of the internet, which promises speeds of up to 2 gigabits per second, which should be very fast. And they want to make use of perhaps better quality images. We're talking about things like 4K, 360 videos, virtual reality, etc. Now let's continue and look at some additional statistics with regard to the internet. If you look at the graph, you will note that developing countries actually is adopting quicker to the internet currently than developed countries. So for a long time, Africa and Asia and India, some of those countries were left behind. But we are starting to picking up the pace, and we are adopting more and more to the internet. So the growth is actually very good. If we look at the internet users around the world, and I've mentioned this before as well, a large amount comes from Asia, and the reason for that is there's a huge population in Asia. Then secondly, we've got Europe, and that's mainly due to infrastructure. And then if we look at Africa, we're actually getting there, but at this stage I think we have more work to do. Now let's look at Africa and where South Africa fits into the picture. Now if I ask you guys, according to African countries, who would be the best or the top internet user? I bet you that most would say it's probably South Africa. Now, it isn't actually. If we look at the statistics for 2014-2015, we would see that we are actually situated third and fourth. So the country with the most internet users is actually Nigeria. Again, the reason being, they weren't limited by monopolies such as Telkom. They actually have internet access in all households, so it doesn't matter where you are, you can probably access the internet. And there's actually a lot of people in Nigeria using the internet, and that's also where a lot of the scams unfortunately comes from. Second on the list is Egypt. South Africa was third. We dropped actually to fourth now, and we were overtaken by Kenya. Okay, so a lot of potential still exists in a lot of the African countries. Now let's go and talk about some of the nitty-gritty about the internet. How does the internet work? The internet allows us to transmit information from one computer to another computer, and these are typically known as hosts. So if a receiving computer is on a network, it's going to receive the message, or it's going to take the message. So it immediately directly receives it, and then it can send it along to the next recipients if they are part of the same network. If a receiving computer is not connected, it actually sends the message along to other computers who will forward it until it actually reaches the destination computer. So a message typically passes through a dozen or more computers or nodes, also known as forwarders. Some of you guys might know about this as routers. And eventually it will reach its destination. The nice thing about this, and this also relates to mesh network topologies, if it happens that a particular node is down, the message will be routed to alternative nodes, and we are guaranteed that the message will be delivered in the end. Now, the internet functions due to the backbone. Now, we've spoken about backbone before. We found it under the network topology for bus topology, which indicated that it was a high-speed network where most of our communication will travel through. Internet work on the same premise. So we've got a high-speed backbone, typically fiber optic cables, in most cases satellite communication, and then all internet messages are directed through these mainstreams, and then everybody connects to that in order to have access to the internet and to get information. Now, how do we connect to the internet? Typically, you need to have access, or you need to work through a network service provider. Now, these are usually large telecommunication companies who have all of their networks connected to the internet, and they allow users to connect to their networks and indirectly connecting to the internet. So typically what you would find is you would connect to companies such as Telkom, and they will have access to the internet and they will make those facilities available to you. So the infrastructure is provided in most cases by the network service providers. In the next discussion, we're going to look at the protocols that we're going to use for internet access, as well as the different terminology that we need to know about. So if we want to work on the internet, the particular protocol that we need to focus on is known as TCP/IP, or the Transmission Control Protocol / Internet Protocol. Now, you will note that there's two protocols involved, and each one of them has specific functions. So if we look at the TCP, the Transmission Control Protocol, we would note that this particular protocol takes the data and it breaks it into small chunks, and these chunks are actually known as data packets. Packets are sent from one computer, from your source computer to destination computer, and these packets can actually take various routes. And the process of the packets traveling amongst various computers are actually known as packet switching. Now let's go on and talk about the Internet Protocol, IP. The IP protocol defines how the data packets must be formed. So it would tell that there should be a source address, a destination address. It might indicate a particular route that should be taken, the size of the packet, etc. So it contains a lot of additional information. Now let's look at some of the other terminology on slides. First thing we need to talk about is an IP address. What is an IP address? And you guys might have heard about this. An IP address is typically a 64-bit number. Now it's actually a 32-bit number which consists of 4 digits. So the digits will indicate the specific address that information should travel to. So if we look at the number here, the last section would refer to the specific computer. That one would refer to perhaps a unit. Sorry, that one refers to a specific computer. That one would refer to a specific unit. That might refer to a company, and the first one usually refers to a country. So that combination gives us a clear indication of where the information should go. Now, as I've mentioned, we're working with data packets. And data packets, the official definition for that is it's actually small chunks of data that would be passed over the internet, and it contains a lot of additional information. And going together with the data packet, we also find IP datagrams. Now, an IP datagram is actually just the insurance that your IP addresses and your data packets conform to various IP specifications. So there's various requirements that we need to enforce on this. Now let's look a little more about the IP address. What is an IP address? Now, as I've mentioned, it's a 32-bit number, so we get 4 numbers, and then this allows us to go and determine an exact computer. Now at this stage, with IP addresses, the current version we're working with is IP version 4. This allowed us to have about 4.3 billion addresses. Now the problem is we are actually running out of addresses because there's too many devices and nodes that wants to connect to the internet. And due to the Internet of Things, where we want to connect all devices to the internet, from fridges to kettles to light switches, we actually require a lot more IP addresses. And that is why they've actually developed a 128-bit version, which is known as IP version 6. Now, the image here, you guys can just perhaps look at it yourself. This is an example of IP version 4, which just means that we've got 32 bits. So if you go and count those bits, that should amount to 32. And then each number is converted to a binary number, zeros and ones, and that indicates a specific IP address. If we look at IP version 6, we see that we've got 8 groups of numbers now, and these are represented by hexadecimal digits. Now you might wonder, what is a hexadecimal digit? If we talk about binary, we talk about two options, 0 and 1. If we talk about a usual numbering system, what we know as numbers, we're actually referring to 0 to 9. So we have 10 numbers. If we refer to hexadecimal, it gives you a combination of 16 possible numbers, 0 to 9 and then A to F. Now if you look at the number here, that is actually the total number of IP addresses that's available for IP version 6. Now to pronounce it is actually very confusing. So it comes down to 340 undecillion, 282 decillion, 366 nonillion, 920 octillion, 938 septillion, 463 sextillion, 463 quintillion, 473 quadrillion, 607 trillion, 431 billion, 768 million, 211,456 addresses. So that's a tremendously huge number. So hopefully in the near future we're not going to run out of IP addresses anymore. So now we need to talk about what is DNS and what is URL. Now if we work with websites, these can actually be referred to as domain names. So for example, if we work with www.uwc.ac.za, that is a domain name that will be registered on a DNS server, so it's going to contain a unique IP address. And if you look at the IP address on screen, that is actually the official IP address indicating the computer where the UWC website is hosted on. Now, IP addresses and domain names are actually managed by ICANN, which is the Internet Corporation for Assigned Names and Numbers, and they take ownership and responsibility for all domain names and IP addresses. So if we look at something like uwcac.za, even though it belongs to the university, we actually don't own rights to that particular domain name because it's managed by ICANN. The next thing we need to look at is what is a URL. Now the URL is the web address that specifies the exact location of a web page. It's made up of letters and words, and it allows us to map the IP address to the host computer. So if somebody tells you please type in the URL, they are actually referring to the website address, for example www.uwc.ac.za. Now let's take it a little further. If we have something like the following, news24.com, this is what it actually means. www refers that we're going to work with the World Wide Web, so this is also known as a host name. The actual company name, in this case News24, is known as the domain name. The extension here tells us a little more about the type of website, and this is referred to as the generic top-level domain name. So what does this mean? If we have .com, it refers to commercial organizations, and typically you would find that in most cases it's international organizations or mainly American organizations. If it contained, let's say, .co.za, it would refer to a company in South Africa. .edu is educational sites, .org, non-profit organizations, .gov, government sites, .net, network organizations, and then .de, .uk for individual countries. Now, if you want to find out about the IP address of a particular site, there's a way to go and do that. So you just open your Command Explorer from your operating system, and you just type ping and the name of the website that you want to refer to, and that will generate the IP address for that particular website. So if you want to see what the address is, this is a way of doing it. Now, before we go away from domains, we need to refer to perhaps second level domain names or domains as well. So in this case, we've got a top level, just .com.edu.org, but in most cases we've got a secondary level domain plus a country level domain. So in this case, .ac.za. So this would be considered to be a second level domain. Now, how do we access the internet? We typically need to work through our LAN servers, or we need to work through an internet service provider. So if you think about the university would be connected to the internet, and if you want to access the internet, you make use of the current infrastructure in the form of wireless networks or perhaps library computers, etc. So all of the LAN users actually connect to the LAN, and indirectly they can connect to the internet. Alternatively, if you want internet for yourself, you need to work through an internet service provider, which are companies that provides internet to people around the world. So you would typically need to pay them a monthly fee. You might need to have specific devices, you need to create an account with them, and then that would allow you to access the internet. Now, since the development of the internet, we're starting to see that something such as cloud computing are becoming more and more important and part of our daily lives. Now, with cloud computing, in the past, all of your resources, your applications, everything had to be installed on your local computer. However, many people are now using mobile devices and they travel with their devices. So there has been a great need for people to have mobility and to still have access to the information. So cloud computing is actually an environment where all the software and storage is provided over the internet, and it can be accessed by a web browser. Now there's a lot of examples for this. You guys might be familiar with storage facilities such as Dropbox, SkyDrive, OneDrive, Google Drive, etc. If we talk about emails, we have Gmail, etc. So there's a lot of these services available. Now, what can we expect in the near future? We will find that computers are going to become smaller and smaller, and at some stage we might not even have computers anymore, where if you have a device such as a smartphone, you might still connect to the internet. TV screens are becoming more intelligent, so by connecting a mouse and a keyboard to your TV and using cloud services, you can technically do all your work on a local TV screen. So there will be less and less demand for our typical computers. Now, why is it important that we make use of cloud computing? Now, if we look at the advantage that it presents to business, it allows them to save on the overall system design, installation and maintenance, meaning that in the past, companies would have gone and developed their own applications. Now they can subscribe to applications over the internet by accessing or making use of cloud computing. So they don't need to worry about installations, they don't need to worry about design, and then all the maintenance would actually be covered by those cloud computing service providers. Now there's different methods of deployment. Cloud computing can either be public or it can be private. If it's public, we typically find that service providers offer all of the cloud-based services to everybody that access the internet. We do find some examples of this as well. Some of the bigger telecommunication companies, cell phone providers, MTN, Vodacom, etc., they do provide free services to their customers. So you might find that they're going to give you an email address and they're going to give you storage space. if we refer to the private cloud, these would include cloud computing where it's confined within private networks, within company networks. So if you think about UWC, private cloud computing would be, they provide you with a student address, an email address for yourself based on your student number. They might provide you with storage capabilities. So while you're a student and while you're functioning in the company, you have access to these resources. Now, I've talked about other devices that will allow us to make use of cloud computing, and we're already seeing a lot of examples of this being introduced. One of them is the Samsung DeX, which is a device. So you will take your smartphone, you will plug it into the device. Your smartphone will connect or function as a computer. It connects to a screen, it connects to a keyboard and a mouse, and it allows you to use your smartphone as an actual computing system. Some other examples that we do find, let's say if you just have a TV with a keyboard and mouse and you don't want to use your smartphone, you can work with a device called Chromecast or Android Stick, which at this stage provides you access to streaming media. So you plug it into a HDMI port in your screen or your TV. It allows you in most cases to connect to the network, to connect to the internet, and to gain access to some of your applications and software that might be linked to your account. In the next discussion, we're going to continue and talk about the World Wide Web.